Yo, 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 what's up, all my cool cats and kittens? Meow. Today we're going to do the Unit 11 test review. All right, I'm filming live in my first period class, so if you hear noises like Brant Bovee, just disregard. First question says, find the surface area. So the surface area means the what would cover this cylinder. So this cylinder has two circle bases. Both can be found by doing pi r squared. All right. And then also if we cut the lateral section of that cylinder and then unrolled it, it would make a big rectangle. So just imagine slicing that cylinder and unrolling it. It would make a rectangle. The height of that rectangle would be 4. And then the base of that rectangle would be found by finding the distance around that circle. We call the distance around the circle a circumference, which can be found by doing 2 pi r, or pi times the diameter. So since the diameter is 12, it's kind of easy to find. It's just, the base is just 12 pi. So the distance around that circle is 12 pi. All right, so what I need to do is I need to find the area of all these figures. So the two circle bases and the unrolled rectangle that wrapped around the cylinder. So since the radius of this thing is 6, how'd you know the radius is 6? Because the diameter is 12, so I know the radius is 6. I've got my two circles. So the area of those circles are pi r squared. And the radius is 6, so it's pi times 6 squared. 36 pi. And there's two of those circles, so let's go ahead and multiply that by 2 because there's 2, 1, 2, and that's where we get 72 pi's. All right, so the area of the bases would be 72 pi, and then the lateral area would be this rectangle here. So the area of a rectangle is base times height. So I'll do 4 times 12 pi. All right, 48 pi. So we've got our lateral area and we've got our area of our two circular bases. So we're finding the surface area, so we're just going to add those things together. All right. Oops. So add them together and we get a total surface area of 120 pi, and it's inches and it's area, so it's inches squared, 120 pi inches squared. Cool. Up next, we have the surface area of a trapezoidal prism. So a trapezoidal prism means that the area of my bases, I'm going to use a big B for the area of my base, is a trapezoid. So 1/2 times the height times the two bases of the trapezoid. So I'm only focused on the trapezoid at the moment. So only looking at the trapezoid, this trapezoid has a height of 3.5. And it has two bases. Remember that on a trapezoid, the bases are the two parallel pieces. So these two pieces here, and one of them is 2 and the other is 6. So 2 plus 6 for my two bases. All right, let's do the math. 1/2 of 3.5 times 8. And when I multiply all those together, I get 14. All right, so my base area is 14, and this is a prism, so there's going to be two matching bases, and you can see in the figure that there's two matching trapezoids, two matching trapezoids. So we're going to multiply that by 2 because there's 2 of them, and that's where we get 28. So my two bases have an area of 28, and now I've got to find the lateral area, and that's going to be made up of all these rectangles along the sides of my trapezoid. So that rectangle is, so it's got a 2 up here and a 4 along the side. So that's a 2 by 4. And then there's another 2 by 4 rectangle on the other side. All right. And then I have this one down at the bottom. This one down at the bottom looks like it's a 2x2 rectangle. And then the one at the top looks like it's a 2x6. A 2x6 rectangle up there. All right, so I can add up all those areas. Those are all my rectangles, all 4 of them. So I've got an 8, an 8, a 4, and a 12. All right, so I have my area of my 2 bases is 28, and then my lateral area of all those rectangles is 32 square kilometers. So we have a total surface area. Add them together, 28 and 32 makes 60 square kilometers. All right, number 12, find the surface area of the square pyramid. Okay, so again, we start the same way. Find the area of the base. So we'll use a big B for the area of the base. And it's a square, so it's just going to be whatever the side length is squared. Or if you're still using little b times little h, that's cool too. They're both 4. Whatever floats your boat. So our base area is 16 square meters. Now this one's a little different. Because it's a pyramid, it only has 1 base. All right, it's not like the prisms and the cylinders that had 2 bases. So this guy's only got 1 base. And another difference is our lateral area isn't going to be rectangles. Our lateral area is made up of these triangles. All right, so I'll use the triangle formula. And now what's cool about these triangles, all 4 of them are the same. So when I do 1/2 base times height, they're all 4 going to be the same. So I'm just going to put a times 4 because all 4 of those triangles going around the pyramid are the same. So we got a 1/2. The base of my triangle, you can see, is a 4. Now when I talk about the height of my triangle, it's got to go perpendicular to that base. So it's going to be that slanted piece. So on other problems, we'll use the cursive L to talk about that slant height. But that does make the height of that lateral triangle there, because it's slanted. The triangle's slanted. So that makes sense. We got a 4.5. All right. So we got 1/2 times 4 times 4.5, and I think that's 9. So, and remember, we have to multiply by 4 because there's 4 of them. So 9 times 4 is 36 square meters. All right, so I have my base area, because there's only 1 base, is 16, and then I have my lateral area is 36. So we're going to add those 2 things together, and we get a total area, surface area, of 52 square meters. All right, so we got to find the surface area of the cone. Okay, now this one's fun because we got the circle part, and we have this funky pizza slice looking piece. So we know to find the circle, we're going to do pi r squared. But to do the funky pizza slice, we're going to have to use a special formula, pi times the radius times the cursive L, which is representing our slant height, which we have here, so that's fantastic. But we are missing our radius. Now you should see a right triangle here, so you're thinking, Mr. Swan, do the Pythagorean theorem. So yeah, we're going to do Pythagorean theorem to find that missing radius. All right. So the radius can be my R, be my A. The 40 can be my B. But the 41 has to be the C because that's across from the right angle. That's got to be the hypotenuse. All right. All right, we got to solve it for R. So let's subtract the 1600. And then square root, and R equals a 9er. So now I know my radius is 9. So the area of my circle is going to be pi times 9 squared, so 81 pi. And I didn't have units here, so square units. And then this is going to be pi RL, so that'll be pi times 9 times the slant, which is 41. And I think that is 369 pi's. All right, and remember, we add those together to get the total surface area. So we have the area of our base and the lateral area of our cone. Put them together, and we get, they're both in terms of pi, so I can't combine them, and it's 450 pi's, units squared. And then we got a sphere. It has a surface area of... I lost something here. It's supposed to say it has a surface area of 144 pi. What is the radius? So somehow this is missing a piece of the question. So in this one, we're going to use the formula. The surface area of a sphere equals 4 times pi times the radius squared, and we're given that the surface area is 144. So I'm just going to fill in I'm just going to replace the surface area part with 144 pi. All right, so we're going to solve it for r, which means I need to first divide by 4 pi. Okay, the pi's cancel out. And now I have 144 divided by 4. So 144 divided by 4 is 36. And on the right side, I have an r squared. You know, we'll square root that to get r by itself. So r equals square root of 36 is 6. So my radius is 6 units. All right, and then number 15 says, what is the surface area of a hemisphere with a radius of 10? So a hemisphere would be a sphere, 4 pi r squared, but divided by 2. So if you want to do 4 divided by 2 is 2, you can use that formula because it's only half the sphere. All right, but I also need to include the base. So the sphere part is 2 pi r squared, the hemisphere part, but I also have my circle, which is pi r squared. So let's do it. We got the radius is 10, so that's going to be 2 times pi times 10 squared, and the circle part is going to be pi times 10 squared. All right, that's 2 times pi times 100, and that's pi times 100. So 200 pi's. Shh. We're filming, guys. All right, so the total surface area is going to be 300 pi's. And that is units squared, whatever they might be. All right.